So ladies and gentlemen, welcome to our second panel discussion today, which is selective soldering systems and solutions. The majority of wave soldering machines have been replaced with selective soldering systems for interconnecting odd-form components, shielding, and other devices. These systems have become considerably more sophisticated in recent years, offering a range of configurations and options. This panel will discuss the best use cases, the configuration options, and troubleshooting tips. I'm joined by a distinguished panel. To my extreme left, we have Andreas Reinhardt from SEHO. Welcome, Andreas. To his right, we have Tobias van Rossem from kurtz ersa. Then to his right, we have Florian Strohmayer from Nordson Select. And next to me, we have Nigel Monk from PillarHouse. So welcome, gentlemen. Thank you for taking part today. So my first question to you is, what percentage of manufacturers are still using wave soldering, and is there still a requirement for it? I'll start with you on the end, Andreas.
Thank you. We see a share of about 50% wave machines and 50% selective machines. There's a small trend to selective machines, but we managed also to increase the flexibility of the wave machines, so to have a higher throughput, even if you have a high mix for wave machines. But a small trend to selective machines, but the share is still about 50 to 50.
Okay. Tobias, I mean, I think on the selective front, the machines have more recently been developed to be able to handle more capability. They're a bit more flexible in some ways. What is your view? I mean, are you seeing a trend more towards them, or?
Well, yes and no.
Yeah.
For us, we can say that. Well, I think that we all can agree that it's nowadays everybody's saying, "Oh, the wave is dying," but I can't find 5 customers who don't have a wave soldering machine. This doesn't mean that they don't have selective soldering. Mm-hmm. For us, the division between wave and selective is about 100 wave machines compared to 350 selective machines per year. So that's what the trend is on new machine sales, but still every customer has applications for wave soldering and will still keep on doing that next to the selective.
Right. Does it depend on the application? What do you think, Florian?
Yeah, and generally, we're from Nordson Select. We don't have wave soldering machines. I cannot give a percentage on from our view, but generally, what we are seeing, pretty much the trend is really going. If the customer has an older wave and he needs to be replacing a wave, the question is very often, or the answer very often, is not a new wave soldering machine. The answer very often is getting from wave to selective soldering, because of more flexibility. Less flux consumption, less preheat consumption, less solder, and in generally the process is more flexible. You can really selectively choose and adjust each individual solder point, which gives you at the end a higher quality for the most of the cases.
Right. Yeah, Nigel. I mean, does it depend on what they're actually making? If you're making consumer products, you're probably doing more through-hole and that type of thing. If you're doing high-end communications, you're not going to be doing boards. You're not going to be doing quite as much through-hole. Just your large odd forms that you'll be doing.
Yeah, it very much depends on the application. The trend that we've seen, again, we don't make wave soldering machines, so the guys there would know more about how much they're selling. But what we're seeing is some of the larger companies are saying that they want to try and reduce their waves within their factories. And that's maybe because, well, we know it's because of the cost of ownership, especially when trying to do a selective product on a wave. Now, your original question was, is there still a need for wave? We believe there is. I think that selective and wave can move to more of a joining in the fact that the wave has certain issues with when soldering through whole components, the dip in the quality, the reject rate, the amount of rework. And I think that's where selective can come in and actually work with the wave also to actually carry on the trend of wave, because there's no doubt about it, selective machines are far slower in certain applications than the wave, and the wave is very much more efficient at this point.
Yeah.
But if you've still got those problems with the quality and the rework, then I think the selective and the wave can very much work together to give you a final product.
Okay. Well, I think the panel pretty much agrees on that philosophy. One thing I've noticed recently is that selective soldering systems have tended to get a bit bigger, the footprint basically, but they're becoming more flexible and sophisticated. But is there an argument for having the larger, more flexible machines for a high mix environment and maybe a smaller inline systems for high volume? Andreas?
Well, basically, most customers should be able to fit all their products in one machine. We have a large flexibility in our selective machines. We can even, in our power selective machines, we can even put a wave inside a selective machine. So you only need one machine, which is of course larger. The main influence we see concerning the size is that we have more and more products that are 20-inch square. So this, of course, it depends on how many stations you have inside of the machine. So you have some kind of minimum space that you need for one machine.
Right.
And of course, you get more and more sensors inside the machine, and yeah, it takes up some space.
So you need the footprint because you don't know whether you're dealing with smaller boards or large 20-inch board, basically. Yeah.
And if you set up a new machine, you should be able to always have this one machine smaller than if you have two machines, one wave and one selective. So you should be able to focus on one machine normally.
Okay. Tobias, what do you feel about that?
Well, I think it's related to the former question and to what Nigel just said. Of course, the wave machines are there for the high volume applications, and of course, this comes with a lot of problems and process problems on certain boards. And the trend is clearly to go more to selective, and then you go automatically to higher volumes, higher mixes, and this puts makes the machine bigger because you need more throughput, higher flexibility in the selective machine, and we see this trend very clearly. We see really this trend to high flexibility and higher volumes. And to come back to your question then, to say, okay, we have a bigger machine for the higher flexibility and then a smaller one for the higher volumes, it's not a trend that we see. We see really, like Andreas said, that people want to do as much as they can on one machine. Of course, it's not always possible. Sometimes multiple machines are needed. But this is not that they say one for the high volume and another one for the flexibility. This is all into one, and you want this high volume, high flexibility in one machine.
What if you're making cell phones, for example? You're making tens of thousands of cell phones, and you just...
Well, maybe if we can say, let's take it to automotive. Automotive is a typical customer who has a high volume and one or two products per machine. And then there can be different solutions for that. Then you can, not from the typical single point wave soldering, you can go to more of a dipping application. Depends also on what the customer prefers, to go for one or the other technology.
Okay. Florian?
Okay. I mean, I'm gone okay with the opinions from these two gentlemen. We've been trying in the past to make a very small inline for higher throughput as well. At the end, the requirements increasing. The customer requires 2 solder ports for parallel soldering. They requires a large preheat zone. They're requiring large board size. And finally, at the end, if we see all these requirements, the machine just get automatically bigger. That's just the case.
Yeah, I mean, the number of features that you're building into the machines are making them bigger. So that was really what my original question was. If you don't need all of these different requirements, then maybe you could do with a machine that doesn't have as many of these features and is maybe smaller.
Sorry, I'm going to disagree with everyone here.
Oh, here we go.
I knew I would. PillarHouse do not believe there is one machine to do all of the jobs. We tend to make a range of equipment, right from obviously the smaller hand load machines for the very small subcontract manufacturers, so they can actually start to use selective soldering machines, right away up to inline equipment. And yes, we do make the big machines for the bigger board handling and bigger processes. But again, we don't believe that unless you need that, why have something so big? So we have smaller modular machines that you can build the machine as you want it. And we do a lot of automotive, whereas you have Q1, Q2, Q3. You can start off with the same machine at a low rate, and then as the quality and the production ramps up, you can add extra machines and extra flexibility as you go. So we do have a slightly different way of thinking, but that doesn't mean that we take away any of the features at all. We just look at the bore sizes and we ramp up as we go.
You look at the application, so you know what the customer's doing.
That's right. We believe there's a machine for each of the customers as you go from, as you said, automotive to medical to backplanes and things like that. We believe there's a machine for each case.
Okay. All right. We'll move on to our next question here. Okay, so nozzle clogging is one of the most common problems associated with selective soldering systems, but most manufacturers have developed solutions to either prevent or alert situations when they arise. What other issues should operators be aware of when operating a selective soldering system?
Well, our solution for nozzle clogging is ultrasonic cleaning.
Ultrasonic, yeah.
And so normally your nozzle should be fine if you have this option. Of course, you need to check the fluxer if it's working or not, and there are also sensors available for this. And one important part is also to really, if you have bad solder spots, to really check your whole process chain and not only look at your solder nozzle, but to check if you have enough flux, for example, and if the preheating is of course okay. Basically, anything can be equipped with sensors to detect the state of the machine, but you need these options to be sure. Otherwise, you need trained personnel to really be able to know what is going on inside of the machine.
Okay. Florian, any other key areas that you can think of that people need to be, keep a watchful eye for out?
Well, if you look into a selective machine, the big advantage, again, to compare to wave soldering, is that you can control every single process that goes on in the machine. So there's a possibility to check the 3 steps in the process, the fluxing, the heating, and the soldering, to make sure that your quality is always the same, that if you run a board today, tomorrow, in 2 weeks, in 2 months, your machine is doing exactly the same job. And these kind of sensors that you're talking about are sensors to make sure that the pressure on your flux tank is always the same, that you always put exactly the same amount of flux on the board, that your preheat temperature, that the temperature that you arrive at your board is always the same, and that your nozzle is constant.
Right.
Of course, 95% of the machines that we build work with wettable nozzle systems, and it's not such clogging that is the problem, rather than oxidation of the surface of the nozzle itself. Yeah. And that's also what you try to do, and that's also what we try to do in a different way with a nozzle activation system, which activates the nozzle again, so you get this wettability. And this goes all automatic. You don't want really manual intervention all the time in your machine. You want the machine itself to check itself and to perform in the same way all the time.
Okay, well that seems to make sense. Florian?
Yeah, in general, we've been using as well an automatic nozzle cleaner to prevent oxidation, to prevent unwetting of the soldering nozzle. Beside that, the customer can decide if he's going for this option or he manually checks it, cleans the soldering nozzle, which is, in my opinion, not the best way to do it as well. There is, on the fluxing side, flux detection sensor to make sure flux is really coming out of the dispenser and to achieve a good result.
Right, okay. Nigel?
Yeah, I think what's been said is exactly right. They're your key features, which is the soldering, the fluxing and the heating. We believe that anything to do with process should be monitored on the machine and should be done automatically. So Our nozzle conditioning system is actually standard on the machine, as is the flux sensor and the profiling of the heater as well. So, but again, as these guys have said, they're the key features that the operator and the engineer needs to maintain as they go along.
Okay, good. All right, so I'm going to come to our last question, or maybe, I'll come to our last question because we're starting to run out of time. So let's start with Andreas. What's the top 3 tips you could give for successfully operating your system? What would they be?
Well, there's only
try and be as short as you can.
One top tip to really look at the data your machine gives you and the information that gives it to you, and don't try to adjust the solder program that worked for 100 days just because one day it did not work. Check if your material is correct and if the maintenance has been performed correctly before trying to adjust anything that used to work before. So this is the most important part, and I think this covers most of the issues we have with selective machines, not the process itself, but adjusting parameters in the wrong direction sometimes.
Sound advice. Okay, we're getting down to the wire here, so let's make it one tip. Tobias.
Well, the tip I want to give is actually that, well, as we said in the former question, that automation is key. I would give the tip that go more into automation, go even more into your traceability. You know that the future that we all look at is this dark factory, this Fata Morgana maybe, but the Holy Grail maybe. And
automation is going to bring quality.
Automation is going to bring quality, and if you want to increase your quality in your process, in your soldering process in general, and selective process specifically, automation is key. Traceability, having the know-how inside the machine, inside the programming of the machine, that will be the future.
Okay. Florian, one tip.
Okay, I will make it quick. So in general, I think for me the most important tip is in generally to keep a good contact with the supplier. Rely on the supplier, make a good maintenance, train your employees, train your operators, train your engineers, and look into the design. It's very important that you look into the design of your board, because this gives you a lot of value if you have a good design.
Okay, that's a good point.
Yeah, everything that these guys have said, but and also understand the process of selective soldering. Probably one of the biggest problems we have is guys said, I've been wave soldering for 30 years, I know selective. It's not, it's a different process. Learn the process, go to classes. I think every one of us do classes on teaching the process of selective. Get a good flux supplier as well. People say, we're using that on our wave, we can use it on selective. Not true at all. Speak to your flux suppliers, speak to your solder suppliers, and actually get the right tools for the job, whoever's machine you actually use.
Yes, some great tips from our panel there. Thank you very much, gentlemen. So I'm going to thank you all for taking part. Andreas Reinhardt from SEHO, Tobias van Rossem from kurtz ersa, Florian Strohmayer from Nordson Select, and of course Nigel Monk from PillarHouse. Thank you, gentlemen, and thank you for joining us.